Sanszee here, and I'm going to talk about the laws of motion. So let's start.
As you can see, the first law of motion is the law of inertia, and it states that objects will continue in their state of motion or rest unless acted upon by an unbalanced force.
Now let us explore how this is possible. So now let us take a ball, and I will take it in red color. But I forgot to draw land. Let me do that. Let me get it here. Yeah. Now this is the land. Now let us extend it because the experiment is big. So let us mark the starting and the ending part of this experiment. So the start is from here. Wait, let me get this line. Yeah, it will start here and it will end here. So now you can see the ball is in rest because there is no unbalanced force. Now let me show what are the forces here. So here this force is nothing but mg, which is gravity force. So now let me do the normal reaction thing, and I will put that in pink. The normal reaction is negative because it is in exact opposite direction. So that would become negative mg, and there's no force here, not here. So nothing is happening. Actually, there's no motion, so there's no frictional force. Now let us start the experiment, and just before that, let me erase all this mg business. Now let us kick the ball and track what will happen. So when we kick the ball, it will roll like this, like this, like this, and reach the other side. But I didn't illustrate it properly. But now let me tell what happened here. Oh, so the ball is here. When we kicked it, then there was a force downwards, which was mg. Let me let me write it down. Mg. Now there was a force which is countering that. Otherwise the ball would sink. That is negative mg. The normal reaction. That is negative mg. And there's a force applied to the right. So that becomes F. And there's in the opposite direction there is another force, the necessary evil. And this necessary evil is frictional force. This is how the object moves, and this is the first law of motion. Let us go further.
So you can see over here that force is change in momentum with respect to change in time. And here the force is directly proportional to change of momentum and inversely proportional to time. And here acceleration is not zero. So unlike the first law of motion, it is different.
Now let us explore how this is possible.
As you can see here,
This is the pen. Let me zoom into this. Yeah, you can see this, and let me zoom out slowly. And from here, I will start and end here to this line. You can see here. So let us first do this experiment and see what does this mean. I'm dragging it, and there you go. I have ended this experiment.
So in this experiment, it was shown that the object moved from one end to another. Let me draw it from here to here. So the object was in rest initially. So while this was in motion, it accelerated. So it due to acceleration, it exerted force. So let me write this down. As I showed in the first experiment, in this experiment also I'm repeating it. Here velocity is 0, then here velocity is maximum, and here again back 0. Here from here to here acceleration, and from here to here deceleration. Thus there's force here, there's another force but in negative. So now this is what does the experiment mean. And I forgot to tell, force is equal to mass into acceleration. So as you can see here, the third law of motion states that every action has equal and opposite reaction. Here the man is pushing the wall, and wall is exerting the exact same amount of force but in opposite direction. And there is mg and negative mg, that is gravity and force of earth on us acting. So thus everything is cancelled, thus nothing is moving.
Thank you for watching this video.